MintParryCrunch asks on the Excel subreddit, find average performance but disregard overlapping months. Hello, I have data that is similar to the posted screenshot without the coloring. I have serial numbers of machines and what software they are running, along with a rolling 7-month breakdown of how much money the machine makes each calendar month. If a software changes in that 7-month period, the report I'm using generates a duplicate row with the same serial number with the new software. I'd like to find the average performance of each serial number / software combo during this 7-month window. However, if there is a change or a duplicate serial number like XX1004, I want to exclude the overlapping values, indicated in gray, and only average the months before or after the change, which are indicated in green or blue, since I don't have the exact date when the change was made. I'd also like to find the average for all machines running a specific software during the 7-month period. For example, in the screenshots, we have 3 machines running Apple software. 2 units ran this software all 7 months, 1 unit, being XX1006, ran this software in 3 months. So I'd like to grab the performance from the 2 full months on XX1006 and the performance from the 14 months on the other 2 units, and divide it by the combined number of months the software was run. I know this is some combination of sum ifs, count ifs, and average ifs, but I really have no idea how to deal with the duplicate serial number / overlapping month issue. Thank you for your help in advance. Now, you are very correct, MintParryCrunch. You will have to use a combination of these sum if and count ifs methods, but indeed the overlapping months form a major problem. So here I made a reconstruction of the screenshot that you provided. So what we have is a list of machines here with their serial number and then the software they are running on. Now, sometimes the software changes on the machine, like in this case. So here we're going from Blueberry to Kiwi. And then you can see the money that a machine made with a specific software in that month. And what we would like to do is to calculate the average for each of these rows. However, there's one issue. With these machines where the software was changed, you can see that we have part of the money generated in one row and the other part in the other row. And the issue is that we don't know for which period this money is. So this could only be for the first day, or it could be for like 29 days of that month in August. So that's an issue. And so we want to play safe, and we only want to take those values that are unique to that software, right? So we are where we don't have duplicate values because we don't know for how long those values represented. Okay, so first of all, what I would like to do is to, for each row, get a filter of those rows containing all of the necessary serial numbers. So for example, here in K8, I want to get a table containing all of the rows that match the current row's serial number. So we can do this with a filter function. So we use the filter function. And how a filter function works is we provided a range, so this entire table, and then we tell the filter function what we want to keep. So that's the next argument. And so what we're looking to keep, that is those rows where the serial number, so that's column B, matches the current serial number. So that would be cell B8 in this example. I close the parentheses. Before I press enter though, let's first use some absolute references so to make sure that we can actually pull this through. So we use absolute references by placing $signs in front of the letter and the number, and we can do this with the shortcut F4. So we want to absolutely fixate the table range and also the column containing the serial numbers. What we do not want to fix and want to leave as a relative reference, that's the current serial number. Okay, so let's press enter. And as you can see, we now get a new table or range containing all those rows where the serial number is the current row's serial number. However, there is still some redundant data. So actually we don't need the first 2 columns in this newly returned table. So in order to get rid of those, we simply change the range of the table. So before we went from B4 all the way to G13. So now we start from D4 and go to J13, just like that. So we only take the values that we're interested in. Just like that, that's a very good start. So next up, we must check if the current row has a value and another row has a 0. In that case, we want to keep that column, otherwise we are not interested. So in order to do that, we must be able to separate these rows. And we can do this using an index function. So if you wrap all of this in an index function, then we can do that. Now, how does an index function work? Well, first we provided an array. In this case, it's a result of our filter function. And then we indicate the row number we want returned. For example, if we're interested in the first row number, then we simply put a 1. If I now press enter, you can see we are only returning the first row. Very good, but we are not only always looking to return the first row, we're actually looking to return the current row. Now, there's multiple ways to do this, but how I would like to do this is to count how many times the current row's serial number has appeared before in the list. That way, we know how many times the serial number already has appeared, and this will allow us to make this one dynamic. So this one we will change by a COUNTIF function. And how this COUNTIF function will work is we will count the range starting from the first serial number up until the current serial number and check if it's equal to the current row's serial number. My bad. So we make sure to close the parentheses, and also very important in this case is that we fixate the first cell of our range, so that always starts at the beginning, and then the second one we don't fixate, so we don't use an absolute reference for the second part of this range, so it always continues to move down. So if we now press enter, that should give us the exact same result like expected. Now we will further have to increase the complexity of this function. And so to help ourselves a little bit, we will actually create variables using the let function, so we can very easily reuse these parts that we'll need multiple times. So let's go about this. So we use the let function, and how the let function works is that we can define certain variables to certain calculation results, and then we can simply reference those calculation results only using the variable without having to retype the entire formula again. Now, usually it's recommended to give like meaningful names to these variables, but I will just use A and B to keep the formula a little bit shorter. So variable A, it will be equal to this filter part here, right? So this entire filter, I copy this, I simply put A there, and then I put the filter part over there. Now I press Alt Enter to better structure my code, and I put the next code on the next line in my formula bar. This is not necessary, but it structures my code a little bit better. So how it works is we're saying, okay, variable A now contains the result of this filter function. And then we can simply reference this calculation by using the letter A. So in essence, we haven't changed anything. All I have to do now is to close the parentheses to my let function. So we have a variable and then a calculation to that variable. And then here we can simply, as a third argument, do another calculation. So if I press enter, you can see same result, nothing changed. We'll do the same thing for the COUNTIF function here. We'll also need that a couple of times. So I copy this like this, and I'll call that B. And now I go to the next line. So variable B equals the COUNTIF function. And don't forget to put a comma, so we have the fifth argument where we are actually having the calculation. So if I now press enter, as you can see, still exactly the same result. So now what we want to do is to check if the current row contains a value, and the next row does not contain a value. That's what we're looking to achieve here. Okay, so how can we go about this? We will have to use another filter function. So we start in our formula with a filter function. And so what are we looking to filter? Well, it's actually the filter we used earlier that's currently stored in variable A. So we want to filter A. So here we can see the usefulness of using these variables. Otherwise, we had to type the formula in A twice. Now we simply reference it with the letter A. So now, as the second argument to the filter function, we decide what we want to keep. Now, what we want to keep are all those columns from the first row that are bigger than 0, so that do contain a number. So that's exactly what we got with this index function. This index function returned the current row, right? As you can see there. And so we want all those values bigger than 0, But not only that, we only want those columns where the first row is bigger than 0, but the second row actually is 0. So for this, we will have to use another index function. So index. Oh, and we make sure to multiply the different criteria, because how it works is it either returns true or false for every column. So a true is a 1, a false is a 0. And so whenever you multiply a 0, it will be a 0. And so we will not use that. So it is an AND condition really. So the condition is the first row needs to be bigger than 0. And now we'll write that the second row needs to be exactly 0. So we use an index function. Once again, as a basis, we take whatever was filtered in our A, so the range that was filtered. But now we don't want to take the exact same row. We want to take the other row. So either we want to take the first row if B returned the second row, or we want to take the second row if B returned the first row. So we can very easily do this with an if function. So we say if, and then we're checking B. So if B equals 1, then we want to return a 2. Or if B was not a 1, so meaning B was a 2, then we want to return a 1. Okay, so all this allows us to do is this f function, it will always give us the other row. So in this case, the first index will take the first row, and then the second index will take the second row. But let's say we pull this true, well, then B will contain the second row, and then this will be the first row. Okay, so now what we need to do is to check if the result from this index is equal to 0, right? So we want to check if the second row equals 0. Okay, then we close the parentheses and we press enter. Okay, and so you can see the result there. What we are getting is the range where only the values in the first row are equal to a number and in the second row are equal to a 0. Very good, but we don't want those zeros. We only want the results of the current row. Well, the current row is actually stored in variable b with the COUNTIF, right? The COUNTIF always gives us the current row. It could either be 1 or 2 in this case. And so depending on where we are, we want to return only the first or the second row of the array we returned. So we wrap all of this in another index function. And so the index will be on the array we just returned. And so what do we wish to return? Well, it is the row that is stored in variable b, like this. Make sure I put my parentheses correct. There we go. So as you can see, now we've only returned the first row. Now let's pull this through to show the effect that we're having over here. As you can see, in the second row, we're actually returning these variables, right? Because we're returning only the row that was stored in variable b. And so how b worked is b counts the number of times that the current serial number has appeared before. And so since it has appeared once before in the previous row, b returns a 2, and that's why we're returning the second row. I could actually still pull this through to see the effect on the other rows. Now we get an error here in this case because this only appears once, but we'll deal with that later. But then you can also see the result here for XX 1006. So you can see we get 1,800 for the first one, and for the second one, we get these results over here. So far it looks quite promising. So all we have to do now is to simply wrap this in an average function, and then we have our final result. So average, and we take all of that. Just like this, we pull this through, and we actually have the correct results. Now, the only thing that's really missing is whenever we don't have an annoying situation where the software switched for a software, well, we also want the correct calculation, of course. So that's something we can very easily check for. So how we do this is, right now we're saying take the average of whatever was returned in that row using the index function. Well, we will use an if function to check if a serial number appears more than once in our range of serial numbers. If that's the case, then we do what we're currently doing. If it's not the case, we do a simple normal average. So we take an if function, and then we want to check. So we use a COUNTIF to see how many times the current row's serial number appeared in this range of serial numbers. So this is a little bit different from the previous COUNTIF. Oh, my bad. From the COUNTIF, in the sense that this case, we are looking at the entire range of serial numbers, whereas with the previous COUNTIF, we only looked at the serial numbers that came before. So in this case, we will also fixate the entire range. Okay, so if the COUNTIF, right? So we're doing a COUNTIF of this serial number here in the entire range. So if it appears more than one, so more than one, then we are actually going to do everything that we've done so far. So now we still have to define what we want to average if the serial number only appears once. So if it's more than once, we are doing all of this. If it's not more than once, we are going to take the average of the current row, just like that. Now we press enter, and now we pull this downwards, and we pull this upwards. And as you can see, this works like a charm. So let's just verify this and take a regular average of these numbers to check if it's actually correct. And yes, it's the same value indeed. So very good. We got the results that we wanted. Now we need to go to the second step of this project. And so here we actually want to calculate the average amount of money that machines made containing a certain software. Now, this is also kind of tricky because for this, we also need to take into account these double months. We don't want to use those, so we want to leave them out. Now, the easiest way to do this is to simply make two more columns, and you could even make them hidden, that will give us the sum and the count using the formula that we used over here. And then using that, we can fill out these values. So let me show you how that would go. So I will simply copy this entire formula, and I will paste it over here. And the only thing I'm changing, instead of taking the average, like we did earlier, we will take the sum. So we take the sum, just like that. And now I pull this through. And so what you can see now is that we're taking the sum of the values that earlier we used to take the average. So in this case, if I take the sum of these values here, you can see it matches 2,925. So it only takes the sum of the variables that were also included to calculate this average. And that's exactly what we're looking for. Now we do the same once again, but instead of using a sum, we will actually use a count. So I copy paste the formula and I'm using a count right now. There we go. And so this will count the number of months where the machine was actually in use. As you can see, very dynamic. It also makes sure to not include these empty months, right? Even for machines that were used only once. So all we have to do now is to add these numbers together in our overview over here. So we're going to do a SUMIF function, right? And what do we want to sum? Well, that is where the software matches the software that is indicated over here. So I select the entire software range. And so my criteria is the software that is indicated over here. So we'll only take those values where the software in this list matches the software here in the current row. And what do we wish to sum? Well, that is of course the sum values that we have indicated over here. Now we make sure to actually fixate our ranges through absolute references. Otherwise, if we pull through, we'll get some errors. So I press enter and now I pull this through. And there we go, automatically very dynamic. You can see there's only one kiwi, that was 2,925, so this matches as well. Now we do a similar approach. We use a SUMIF once again. Same thing, we're looking at the software of the current row that needs to match, and then we add all of the counts together. Once again, making sure to use absolute references for our ranges so we can pull them through. Just like this. And as a final step, we simply divide the sum with the months to get the average performance of certain software. There we go. And so the result we get is that the Banana software is actually the most profitable software. And you can also see our most profitable machine also runs on the Banana software. I hope this was an interesting case study. It was quite a difficult challenge to come up with these functions, especially this one. Once again, let function was a true lifesaver in making our function a little bit easier because we could abstract away some of the logic behind those variables, making it a little bit easier. So the difficult part was really coming up with the idea to split the rows and then compare each row independently.